starting. We already started, then I realized I did not. Why is that not moving? Good start. Already struggling. All right. We were talking about how, go ahead and write all these down, but this was a synopsis from Friday. When I say inverse, you say switch X and Y, domain and range exchange. This is what happens with a logarithm. You'll see this go about in the notes. Then we just talked about the different types of logarithms we can have, but for sure they have vertical asymptotes. We got to know that. And then I literally did go over this real fast. This is for if you were absent. You can go ahead and read all these. We're going to go over all this right now. All right. So the first thing we were doing is looking at this picture. Of course, as I plug in bigger x's, the y's go off to infinity. So that's our right limits. And then reminder, this is not new. This is why I'm not spending a lot of time on it, but I will change this color to green. Input, say it. Output. Input, output. Input, output. I'm trying to get closer and closer and closer to 0 for x, and then looking at the corresponding y value. This is why this drives me nuts, people that can't figure this out. As a matter of fact, I'm going to go ahead and highlight this, I guess. And that's what it means to be 0 plus. That means to the right of 0, what is the y doing? It's going to negative infinity. That's what input output said. And you people that cannot figure this out, this is when we're going to infinity. You're looking at that arrow. Now, again, that arrow is slowly going up, but it is going up. And you people that can't figure out the to the right, sorry, I couldn't get the right words, of 0 is just that arrow. Where's that arrow going? Down forever. Should not be being missed by anyone anymore. This should be 100% across the board, easy points, blah, 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 blah. Problem is it's not, and we got some issues with that. Left and right, what does that mean? To go right, that's my right. Input, output, input, output. Just by looking at that, what are my outputs doing? Going what? Down. Okay, and they are slowly going down to infinity. So that's limit of f of x as x goes to infinity. That's the x's. The y's are down. So they're going to negative infinity. All right. And then I guess because I picked green for some reason, input, output, that should be enough. Hey, maybe one more. Input, output. That's very tight right there. So that's the limit, again, of f of x as x approaches 0 plus. And that's positive infinity. Okay? These are all things we should already know. And then, you know what? I really don't like this question because actually some things are wrong here. 881. Yeah, I guess it's just, here's what they're trying to get you to understand. This is an exponential set of data. I guess what you're supposed to see with this exponential data is it's increasing, right? 2, 6, 8, 2, 3, 6, 27, 8, 81, right? Increasing graph. Hello? Braden? What's the answer to the question? You weren't listening. I caught you. All right. So anyway, you made the video though, Raiden. That's nice. Okay, so you're welcome. All right, and then they say the log. So it's the log based off of this exponential. Bases are the same. Have the points 327, 27, 81. Here's what they're trying to get you to get. And I'm just going to go back to our notes from last Friday. Okay, look at that. Remember, exponential red. Logarithmic green. What's this exponential doing? Increasing or decreasing? What's it doing? Increasing. What's its concavity? Concave up or concave down? That's easy. Up. What's the logarithm? Increasing or decreasing? Increasing, but what's its concavity? Down. That's what they're trying to do in this cryptic question right here, which I feel is, where am I at? I'm lost. Okay, in this question, what they're trying to get you to understand. So you know what I'll do? I will do average rate of change because this is something they ask you to do all the time, no matter what we're dealing with. Even trigonometry next semester, they're going to keep asking average rate of change, which is just slope between 2 points. You cannot be missing this. We've done this a lot. 81 minus 27, and then 27 minus 3. then whatever you get for that. Now, that'll be a positive, so that means it's increasing. From 3 comma to 27 comma, we have an increasing slope. So the graph is increasing, but the slope's going to be really small compared to these average rate of changes. So what they're trying to get you to understand is it's concave down. That's, I think, hard to really do. To really know it's concave down, I should have one more coordinate to compare another rate of change going left to right. So I don't want to get, we have enough stuff. You know what we have to do today? We have to know how to graph. And that's what I really care about. And what I really care about is, do you understand concavity? And you do. Like this one, what's this? Concave up or down? Up. So it's just a cryptic way of trying to get you to understand what happens when you find the inverse of an exponential. This exponential, where it came from, would have been concave down, believe it or not. Then when you invert it, it turns into concave up. That's the relationship. And then what is it doing? Increasing or decreasing? Decreasing. So what of the exponential it came from? What's this? Concave up or down? That's all I really care about. Is it increasing or decreasing? That's nothing new. Nothing new at all. So you can say this other one is increasing at a decreasing rate, right? Remember those sentences? Yes, Mr. Samuelus. And then let's actually get into input say it's. Okay, so we're going to go to this, and this is why we did our quizzes last Thursday. The big evaluation quizzes. What's log base 3 of 3? Here we go. What's log base 3 of 3? 3, 2, 1, go. 1, because 3 to the first power equals 1. What's log base 3 of 1? 3 to what power equals 1? Did you get that, Raiden? He hasn't answered one of these questions yet. I haven't seen his lips move. What's log base 3 of 9? 2. You want to get nuts? This isn't really nuts, and this was actually on the quizzes. What's log base 3 of 1/3? 3 to what power equals 1/3? -1. Raiden answered first. Don't hurt your tongue. White, sorry, nothing funny yet? Okay. All right, we'll try. All right. So, first things first, this is a vertical stretch. Okay, fine. They asked for the transformation. Sometimes I get stuck with my words. A lot of words I have to access in my brain. You know what I'm actually, I forgot to ask this. What's log base 3 of 0? Can I take 3 to a power and get 0 as an output? No. So guess what I'm going to plug in the chart first? Exactly what I just said. The naughty value. So what's log base 3 of 0? Undefined, doesn't work. What does that mean this is? That's where the what is located. The asymptote. Now I'm gonna write these evaluations down. Running out of ribbon there. Then the last one I'll put down here. So this was 2 log base 3 of 0. That's the input output. And that's undefined. You know what? I eventually did sketch a graph of this in the other hour. So that means you have an asymptote at that spot. And then I am going to do a quick sketch of this over here. Because it does help. It does help to do domain and range then when we know these things. Okay, what's the next one I'm going to plug in? Next one I'm going to plug in is 1. Okay, I thought that was getting a little weird there. What's log base 3 of 1? What's log base 3 of 1? 0. What's 0 times 2? What's 0 times 2? Not 2, it's 0. Ay, caramba. This is why you're afraid to answer questions out loud. But, I was wrong. Everyone's making fun of me now. Got to get over that. Give me a break. I make a fool of myself every single day. Believe me. I'm just used to it. So log base 3 of 1 is 0. 0 times 2 is 0. And then I did that point. What's the next one I'm going to plug in? Log base 3 of 3. You have to do this without a calculator. Oh, no. You're going to hate me. I already do. You should put 1 and 3 here. I wanted to squeeze a point in there in between. My bad, dogs. If you have an eraser, fine. If not, just do it after. But I do like putting them in order. So 1, 0. Okay, now, what's log base 3 of 3? What's log base 3 of 3? 1. Oh, and then I have to erase this. I really screwed up, everybody. Okay. So I just want my notes to be perfect. 2 log base 3 of 1, 1, 1, 1, 1. And then 2 log base 3 of 3. What's log base 3 of 3? 1. What's 1 times 2? 2. 1, 2, 3, 1, 2. Just a real quick sketch. Now, usually what we want is like 3 points. So this next one is you don't really need, but what's next? Log base 3 of what is nice? Log base 3 of what? I heard someone say 9. Why? What's log base 3 of 9? 2. What's 2 times 2? 4. So you got to know your order of operations. Log base 3 of 9 is 2, and then 2 times 2 is 4. That's way out here and not so far up here. Just make a little, don't go crazy. All right, then what I want to put here is, well, what did we just ask before? Log base 3 of 1/3, right? What's log base 3 of 1/3? What's log base 3 of 1/3? -1. What's -1 times 2? You guys are way better at answering questions at that other hour. Don't do anything. Just sit there and look at me. All right? With angry eyes. 1/3, comma, -2 first hour. So that is why we see this picture here. Input, say it. Output. Oh, and then I didn't put this in there too. I'm not writing this anymore. Log base 3 of 1/3. Log base 3 of 1/3 is -1. -1 times 2 is -2. Okay? So I've been saying input, output all along, not writing where I'm getting my evaluation because we should know how to do that. But I wrote it because of logarithms, and how it piggybacks off of yesterday. Fine, transformations. Let's get it over with. If you don't know this, vertical stretch. Probably shouldn't have done that first. It's also a vertical flip. Vertical flip. What's the -3 do? Say reflection. Good. I heard someone say it. Right 3. Right 3. All right. Input, say it. Input, say it. What am I going to put first that's bad? Not 0. And actually, that is bad because 0 gives me -3. You can't log a negative number. It's 3. And it just drives me nuts. We've done this a million times. We've done this with quadratics. What do I plug in first? 3. We've done this graphing square roots. What do I plug in first? 3. You plug in the thing that makes the parentheses 0. We did this with exponentials. All right. If it was 3 raised to the x minus 3, you'd plug in 3 because you get the 0 exponent rule. But now you plug this in because this is naughty. This doesn't come out as a result. This is, log base, in this case, 2 of 0. This doesn't work. You cannot evaluate a logarithm at 0 or negative for an x value. They don't work. Log base 3 of -3, wrong. Okay, well, this is log base 2, but same idea. So then what do I plug into? Skip. Do I plug in 2 or 4? Which one? 2 or 4? 2 or 4? Not 2. You just pick the first number. 2 or 4? Why 4? Because that makes it positive. You can't log negatives. Okay, and I'm not writing this out anymore. What's 4 minus 3? What's 4 minus 3? Drink. 1. There we go. Log base 2 of 1 is what? What's log base 2 of 1? 0. What's 0 times who cares? 0. Who cares? Someone just answered. They didn't. I just thought that'd be funny. All right. So 1, 2, 3. Vertical asymptote. That's why. Right here. Yoink. And then 4, 0. Proof. You got that little point there. I skipped because I do want that fractional value. A little bit tough, but 2 as a base isn't bad. Let's make this easy. What do I plug in next? What do I plug in next? Because I have a base of 2. Well, gee, I want this to be 2. So what do I plug in next? Because nobody's answering. 5. Because we're all looking around at the ceiling tiles. 5 minus 3 is 2. What's log base 2 of 2? 1. What's 1 times -5? -5. So it's 1, 2, 3, 4, 5. Oh, okay. 1, 2, 3, 4. There's that flip. And then you know what? The next one that would be nice. 2 is a little bit tough. That stretch of 5 is really stretching this out. But the next one I'd plug in, how do I get 4 out of this, is 7. 7 minus 4. 7 minus 3 is 4. Log base 4 of 2 of 4, sorry, is 2. 2 times negative 5 is negative 10. So it's 5, 6, 7, and then way down. It is eventually going to go like this, though. You know, it's because we have a base of 4 that's taken longer to like flatten out, but it still is decreasing forever. All right, and then here's the one I want to put here. Y 3.5. Guys, we just got to have some sort of fractional knowledge. 3.5 minus 3 is a half. What's log base 2 of a half? What's log base 2 of a half? Negative 1. 2 to the negative first is a half. So negative 1 times negative 5 is 5. Why I plug that in? 3.5 comma 5 is somewhere up there. This is proof that we're getting close to an asymptote there. This didn't ask you to graph. Oh, and as a matter of fact, I screwed up all of these. What's the domain here? 0 to infinity, right? Here it is. And then the range is always. And then I'm only going to graph 2 of these that we have over here. So the domain of this, though, is different because it got moved 3 right. And then the range is still all real numbers. Okay, and that was all written up there. You can see it from the picture, though. All the previous stuff is great, but it's, you know, we can figure it out without having to read through it. Okay, and then we're going to do this, and then I'm going to skip to the last one. I guess on Monday, no, not Monday, tomorrow, Tuesday, some more graphing, you know, I guess. Okay, input, say it. Well, they're not even saying that now. It's rebellion. What am I going to input first? That's naughty. Negative 2. Okay. Why? Negative 2 plus 2 is 0. That can't happen. That's why there's an asymptote there. Now, they do like this. I kind of prefer on a test that we have an x-axis so we're all in the same spot. But I know where the asymptote is, and I know I'm going to have to go right of this. So I want a lot of space right. Gives me some options to input, output, and actually see the picture really well. So that's why they give you options where you put your x-axis. I don't know. It's nice. All right, and then skip. What am I going to plug in next? Negative 3 or negative 1? Negative 3 or negative 1? Negative 1. I heard someone say negative 3. Negative 3 gives me a negative. You can't log a negative. So it's negative 1 that I plug in there. Negative 1 plus 2 is 2. What's log base, or negative 1 plus 2 is 1. Went too fast there. What's log base 3 of 1, everyone? 0 minus 4. Negative 4. So we're at negative 1, comma 1, 2, 3, 4. All right, we'll do domain and range after we're done graphing. It's a base 3. So what would be nice next? Well, it'd be nice if I got 3 on the inside. How do I get 3 on the inside? Plug in what? What do I plug in? Oh my gosh, you guys are scaring me by not answering. What plus 2 equals 3? 1, Mr. Samuelis. Now, the superintendent's out there. He thinks I'm yelling at you. No, I'm teaching. All right, 1. Oh, hey, God, this is like hit my head up against the wall moment. What's log base 3 of 3? What's log base 3 of 3? 1. What's 1 minus 4? And if you don't know anything I'm talking about, what was our quizzes on Thursday? It was evaluating log base 3 of 3 in our head and understanding it's an exponent. 3 to what power equals 3? 3 to the first, right? But then 1 minus 4 is negative 3, continuing with the input output. 1 comma 1 2 1 comma 1 2 3. I feel like I'm missing. All right, and then what's the next one? Well, gee golly, I'd like 9 in there. How do I get 9 in there? 7. 7 plus 2 is 9. What's log base 3 of 9? What's log base 3 of 9? 3 to the second equals 9. So it's 2. What's 2 minus 4? -2. And then I actually played a little game. 1, 2, 3, 4, 5, 6, 7, comma, -2. What if I asked you what's the x-intercept? X-intercept. Well, I would need this to turn into 4. What's 4 minus 4? What's 4 minus 4?
0.
0. I'm covering this up. I don't know if you can see my hand there. My big fat head's in the way. Okay. All right. So how do I get that? 3 to what power equals 4? Or what? 3 to the 4th power equals what? That's it. 81. How many times did we have that Thursday? Then we have 81 and 3 different times. 3 different times. So how do I get this to be 4? What do I plug in? No, sorry. How do I get this to be 81? I plug in what? And someone said the number right. 79. 79 is where the x-intercept is. Why? What's 79 plus 2, everyone? 81. Someone got their calculator up. What's log base 3 of 81? What's log base 3 of 81? 4. What's 4 minus 4? 0. Here's where the x-intercept is, way out here, comma. You know, that's just proving. Oh, I didn't do my fractions. How do I get 1/3? You know how I get that? I plug in negative 1 2/3. Because negative 1 2/3 is 1/3 away from 2. So this is simple fraction work. I'm afraid of this. Negative 1 2/3 plus 2 is 1/3. What's log base 3 of a third? What's log base 3 of a third? Negative 1 minus 4 is -5. This is just proof that at negative 1 2/3, you're at one little notch below. So we do have this graph here. Remember that x-intercept? Man, this sucker doesn't hit the x-axis until 79. You're not even close to 79 there. So you don't have to do that. I just thought I would share. Sharing is caring. Oh, and I care. I care so much it hurts. And then, gosh, if you got the picture, the end behavior is easy. Limit of f of x very slowly as x goes to infinity, very, very slowly, but it does go to infinity. 79 gives me 0. Then the next one has to go way out to get me 1. But I can go forever out for x. That means y can forever go up. Very slow. My asymptote's at x equals -2. So my limit behavior right by that asymptote. Do not overlook that. That's asymptotic behavior limit, not end behavior. This is an unending end here that goes forever. This one's like getting boundaried by this asymptote. So how do you write that? That's -2 positive. Okay, that's on to the right of -2. That's the notation. And by golly, Willikers, you better understand at this point that that's where that arrow is. So therefore, it's going to negative infinity. By golly, gee Willikers, you better understand that that's rising forever. That's where those answers are coming from. All right, I felt like skipping this next one because this one just has a little bit of a reflection. I guess on Monday we'll do a y-axis reflection, see how that works. Input, say it. What's the first input value? That's naughty. That gets me my asymptote. -1 is right. We're getting more people saying stuff that means we're in tune. I like doing 0 with the slash through it. That's still way over here, so maybe draw your axis here. I don't care. You don't have to go. Where'd you put that? How many spaces? Who cares? Just put it somewhere, and then put the x equals -1 right next to it. Okay. All right, and then we are going to input 0. I'm going to skip one for fractions. It is a base 4, so that fraction might be a little bit tougher. 0 plus 1 is 1. What's log base 4 of 1? Now, I screwed this up last hour. What's log base 4 of 1? 0. -0 still 0 minus 2 is -2. So it is 0 comma -2. Okay? We'll do the fractional last. What's next? It's log base 4. So I got to get 4 in there. How do I get 4 in there? Plug in 3. Was that Raiden? I think that was his voice. Nice. 3 plus 1 is 4. What's log base 4 of 4? This is what I screwed up last hour. What's log base 4 of 4? 1, but then it's negative. I screwed that up because that negative's floating on the outside. So it's actually negative 1 minus 2, which is negative 3. And I caught my mistake, 1, 2, 3, comma 1, 2, 3, because I knew this graph had to decrease now because it got flipped. I knew what the graph should have looked like, but I made a mistake on one of my points, and the point was in the wrong spot for that. Okay, let's keep going on the easy side. Oh no, this turned into 4. What's the next power of 4? 16. So what do I have to plug in? 15. You gave me that answer. So good, I have space for it. That's why they made up these coordinate planes. 15 plus 1 is 16. What's log base 4 of 16? 4 to what power equals 16? But it's negative right now. Negative 2 minus 2 is negative 4. So you are right on the 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4. All right, and then on the other side, here's the fractional thing. I need this to be 1/4. So you know what I have to plug in? You guys know? Negative, I heard someone, 3/4. Because when I plug in negative 3/4, negative 3/4 plus 4/4 is 1/4, or you're 1/4 away from 1. So that does turn into 1/4 on the inside. What's log base 4 of a fourth? Careful on this. What's log base 4 of a fourth? Negative 1, but then what's negative 1? 1 minus 2 is negative 1. That's the one I screwed up last hour. I didn't tack on the negative, and I got negative 3 as an output. That just proves, that we got this behavior here. All right, and then we're good. I'll go ahead and stamp away. I don't think I need to do 3 of these. It's really just getting through the input-output and knowing what your shape should be looking like. Domain is negative 1 to infinity, not including negative 1. We never get there. Range. My infinities are better today. Thursday, they were terrible. And behavior, limit of f of x as x approaches infinity. Where's that going? Where's that going? Negative infinity, very slowly. The asymptote is at x equals negative 1. And then the limit by that asymptote, limit of f of x, as x approaches the asymptote, negative 1, from the right. Where's that going? This is why this drives me nuts, people missing this. And back in the day when we did limits, we definitely did the highlighting. That's going to infinity. Okay? Back in the day. But I'm bamboozled how people are still missing these limit statements. Oh, you talk about being severely and totally behind at this point. Oh, and on a positive. Happy Thanksgiving coming up.